Welcome back to Learn with Numbers. In our last video, we talked about the mission of our channel, and today we're starting our first project. This is lesson 1.0, the planning phase of project 1. And by the end of this lesson, I want us to be familiar with these three concepts: population, sample, and to estimate. And your job between now and the next lesson will be to interview 15 to 20 people and write down their answers in a physical notebook. I want to have a motto for each of our lessons, and the motto for today is to judge a soup, you only need a spoonful. This scene will be familiar to those of you who play Stardew Valley, and for those who haven't heard of it, it's a farming and adventure game where you build relationships with the locals in a small town. And every summer the town holds a Hawaiian-style festival called Luau. The townsfolk bring ingredients to add to a communal soup, then the honorary guest, the governor, takes a spoonful and judges the soup of the year. If he likes the soup, the whole town likes you more. And this story is a very useful analogy to understand statistics. In order to tell how salty, spicy, tangy, and tasty a soup is, we don't have to separately taste each and every ingredient people bring to it. We can just take a random spoonful of the mix and make our judgment. This is where statistics gets most of its power from. The world is full of things we cannot fully observe, but we can take a partial taste and it can give us insights into things that we don't have direct information about. In statistics, we call this large pot our population and the spoon our sample. And we can think of the governor's judgment as an estimate of the true taste of the soup. We use the sample to estimate to better understand the population overall. This process of using a sample to understand a population is called statistical inference. This soup analogy works beyond explaining population and sample. If you have a chunky soup with meatballs, you may need a bowl to properly taste it instead of a soup. If you see oil at the top, you may need to take samples from different parts to make a fair judgment. And if the soup is fresh and the flavors didn't get to mingle yet, you may need to stir it a little bit before giving it a taste. All these cases have different names in statistics, and we will cover them more in depth in future lessons. For now, let's focus on the terms of the lesson: population, sample, and estimate. Okay, we got the soup analogy, but let's give a few more examples to these concepts. If you interview 20 people in your school, then those 20 is your sample, and everybody in the school, including the 20 you interviewed, is the population. The whole point of studying a sample is to make an estimate, an educated guess about the whole population based on what we observe in the sample. If the average sibling count in your sample is 2, then you can guess that the average sibling count in the whole school is around 2 as well. And you might say, if we take a sample because the population is too large to measure, then with all the technology and access to data we have today, we may not need to estimate anymore. Unlike 20 years ago, we can gather data on almost everything and everyone. So does that mean there is no need for statistical inference? There is no need for estimation anymore? And of course, the answer is no. Statistics is not dead yet, but the question is absolutely rational, because the common explanation of why we study a sample is not capturing the whole story. The reason we can't study the whole population is not always about its size. It's often the case that population is fundamentally impossible to observe. Let me give you a few examples. Let's think about weather forecasts. The population here includes both the past and the future weather events, and we can't observe the future ones. We can't know tomorrow's weather today. But we use the historical data, we use what we can see as a sample to estimate a part of the population that hasn't happened yet, that we can't observe yet. And another example of this is destructive testing. Think about how we know the dust and water resistance levels of iPhones, for example. Before the phones hit the market, third-party certification labs like Intertek or UL receive a sample from Apple, and they put the phones in pressurized water tanks until their internal seals fail. If Apple had to test every single phone this way, they wouldn't have any brand new phones to sell. So when the test itself damages the product, we need to rely on a sample. Extreme example of the destructive testing is with fireworks, bullets, missiles. If you test an entire population of these explosives to make sure they work the way you want them to work, you wouldn't have any products left to use or sell. And let me give you one last example. Let's think about paleontologists studying T-Rex remains. The true population is every T-Rex that ever lived, but most of their bones turned to dust millions of years ago. Today, we have only found about 32 relatively complete skeletons, but with that handful of fossils, we can estimate the historical population of T-Rex to be in the billions across North America. So population is a more abstract term than just too big, and statistics is not just a shortcut for counting big numbers. Later in the course, we will think of population as a data generating process, but for now, we can think of it as everything we want to know about a topic. And statistics as a set of tools we rely on whenever we need to understand what we cannot see using what we can see. And today we're going to join these paleontologists and conduct our first research project. Instead of digging the ground for fossils, our method of data collection will be interviews, which basically means asking people questions. If you ask people the same set of questions, that's called a structured interview. And if you send people these questions in a mass scale without facing them or calling them on the phone, that's called a survey. And our method will be a structured interview. You're going to interview 15 to 20 different people. They can be classmates, family, friends, anyone you have access to, and you're going to record their answers in a physical notebook. And an important rule I want us to follow is to keep the identities of the respondents anonymous. You can use nicknames, numbers, it's up to you, but we want to respect the privacy of the people who share their own data with us. All right, let's get to it. Here are the questions you will ask each person. The first question, if they want to choose a nickname, they can choose their own nickname. The second is their birth year. The third question, how many siblings they have. Fourth question, how many first cousins they have. And then how many hours a day they sleep. Do they have a pet? If they do have a pet, which species it is. And what's their hometown? What's their favorite color? And a unique question of your own. You can choose that question, and it doesn't have to be the same question for everybody. It's up to you. All right, let's pause the video here and think about these questions and some problems we might encounter when interviewing the people or putting the questions into a spreadsheet. All right, the first problem that we might encounter is with the question, how many siblings do they have? Some people include themselves when they answer this question, so we need to clarify that we're asking them how many siblings they have, not including themselves or including them. So it has to be clear and it has to be same for everybody. And this next clarification I want us to do for the cousins, not including your siblings and yourself. Another clarification we might have to make is with sleep. People sleep different hours on a weekday or a weekend. So it's good to be consistent and ask a question that we would receive and ask a more consistent answer to. So another clarification we might have to make is with the hometown question. So you might have to replace that with state or country based on your population, based on who you're interviewing. And another problem we might encounter is the favorite color question. People might give very specific colors, and I want us to keep it consistent. I want us to keep it limited to rainbow colors and black and white. So that is red, orange, yellow, green, blue, purple, black and white. And we have a real assignment to complete before our next lesson. So go out there, interview 15 to 20 people and come back with that notebook for your next lesson. And if you want to help me complete this assignment as well, go to the description of the video. You'll find a Google form link where you can take this survey yourself and answer these questions. Hello, Nani. Yeah, and that way I can have a sample to study for our next lesson as well. In lesson 1.1, we're going to take those answers and turn them into a dataset in Google Sheets. Remember our motto for the day: to judge a soup, you only need a spoonful. Your 20 interviews are the spoonful, and the whole school or the whole hometown is the pot, the whole soup. So let's see what we can learn about the soup based on our sample. See you in the next one.